Okay, we're going to take a look at some sample problems where we are completing nuclear reactions. Things I'm going to need to know that I'm going to need to have handy in order to complete these reactions include the following. I need to remember what an alpha particle is, and that an alpha has a mass of 4 and a charge of 2. It's the same thing as a helium nucleus, so sometimes you'll find that people write this, and it means the same thing. And if you want to do that, that's fine. A lot of times that was the common notation if somebody was typing something and they didn't have a typewriter with an alpha symbol. We will also use beta particles. If I just say beta, it implies that I mean a beta negative, which has a charge of -1 and no mass relative to a proton. It does have a mass. It's the same thing as an electron. Generally, we call it a beta particle if it comes from the nucleus, whereas if it comes from surrounding the atom, we tend to call it an electron. But if you want to use them interchangeably, I'm okay with that. Third, we have a positron. If I tell you beta positive, that means positron, and it'll be 0, +1. We probably won't use gamma very much, but if you see gamma, it'll be a 0, 0. Other things that may come into play, proton is a 1, 1, mass of 1, charge of 1. It's the same thing as a hydrogen nucleus. And then neutron has a mass of 1 and a charge of 0. So let's take a look now at these sample problems. The first one says potassium 39 undergoes beta decay. Potassium is element K. That's saying this one has a mass of 39. Now, if I go to the periodic table and I find potassium on it, I find the atomic number is 19. One of my products is a beta. A beta is a 0, -1. And now I can deduce what my other product is. To deduce what my other product is, I just need the math to add up. I want to view my arrows in equal sign. And then after that, I'm just doing simple arithmetic. 0 plus what number equals 39? That should be a 39. I need the bottom numbers to add up too. So what number, when added to -1, gives me 19? That number is 20. Now, to identify what goes here, I'm going to go to the periodic table and I'm going to look for element number 20. Element number 20 on the periodic table is calcium. And this is my completed reaction. So the rule of these reactions is that the numbers up here need to sum on both sides of the equation. So 39 equals that plus that. And then the bottom numbers also need to sum, where 19 equals that plus that. Let's take a look at another example now. On the left side of the reaction, I have a 1 and a 3. So that totals 4. So on the right side of the reaction, it must total 4. The bottom numbers on the left total 2. So the right side of the reaction, that must equal 2. 4, 2. I have two options. I can either say helium or I can say alpha 4, 2. All right, the next one. Aluminum 27 plus a helium yields phosphorus 30 plus something else. I need to go to the periodic table to figure out for aluminum what its atomic number is. Periodic table tells me the atomic number of aluminum is 13. The atomic number of phosphorus is 15. So now on the left, total 31, and that's a 30, so this must be a 1. On the left, a total of 15. On the right, a total of 15. So this number here must be a 0. What particle is a 1, 0? A neutron. Okay, if you want to try the next one and then check back for the answer, or the next two and check back for the answer, do that. And if not, I'm going to go ahead and finish them. Chlorine 37. Chlorine has an atomic number of 17. Sulfur has an atomic number of 16, and an alpha is a 4 2. This must be a 1, and 35 plus 4 is 39. This must be a 2. Element number 1 is hydrogen. This would be a particular isotope of hydrogen that has a mass, has 1 proton and 1 neutron, known as deuterium. The hydrogen we saw up here, which is a hydrogen 3, that's called tritium. Okay. Radium-218 decays by alpha. Ra-218 is going to emit an alpha particle, and I need to figure out what my other product is. Going to my periodic table, radium has an atomic number of 88. This number will be 86. This number will be 214. Back to my periodic table to find element 86. Element 86 is radon. Okay. For this next set, we now need to reference table 9, which is the masses of the light nuclides that we use for doing binding energy. It's linked here in your notes. It says decay of sodium 24, Na24. Sodium is element 11. I need to go to the chart to figure out how sodium 11 decays. When I check the chart and find Na24, it tells me that its mode of decay is beta. So one of my particles is a beta, and I'm going to deduce what the other particle is. Mathematically, this must be a 24 and that a 12, yielding magnesium. Carbon 11, however, when I consult the chart, tells me that it decays by positron emission. So rather than getting a beta negative, I'm going to get a beta positive. 7 and 11, element 7 is nitrogen. Okay, last, decay of fluorine 20. Fluorine from the periodic table is element 9. According to my nuclides cheat sheet, fluorine 20 decays by beta, giving me 0, -1. This must be a 10 and that a 20. Element 10 is neon. You should be just fine to do your homework. Let me know if you have any questions.